the review that we're going to do in class today. So what we're going to spend a lot of time in class today doing is actually a Mad Libs review of triangle similarity. So I'm going to send that to you guys with the answer key. Feel free to do as many problems or as few problems as you want. I know that we'll be working on it in groups in class. So if it seems like a lot of work to get through all of the different problems, or you feel like you've got it and you don't need to do it, or pick out the ones that you want to, whatever you want to do with that is great. So I will send that over with the video. The other thing I'm going to do in class today is talk about the Chapter 6 test. So the Chapter 6 test is at home tonight or tomorrow, whenever you're going to take it. And a couple things for that. So you are allowed to use your theorems and postulates sheet for the Chapter 6 test. Make sure you have that filled in because we do have some theorems and postulates that we learned, especially toward the second part of the chapter. So things that you want to make sure that you know are the postulate and two theorems about how we can prove triangles are similar. So we've got angle, angle, we've got side, 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 and we've got side, angle, side. So those are our three, one postulate and two theorems that we can use to prove triangles similar. So make sure that you have those and you understand those, and that's basically what we'll be practicing in the Mad Libs today. The other thing that I wanted to point out for the test is make sure that you understand the theorems that have to do with parallel lines. So when you have a triangle that has a third side that has another line parallel to that, that makes the two sides in the same ratio. So make sure you understand that, or the converse of that. If your two sides are proportional, then the two lines are parallel. And I can do an example of that here at the end here. And then the last kind of one-off theorem that we learned about, if you have a triangle that's cut by a bisector, and then that makes the two sides parallel as well. So I'm going to do a couple of examples just to review for the test, and then we'll let you try out the Mad Libs. All right, so let me switch over to here. I think that worked. Did that work? Oh, okay, there, I'm still here. Okay, so one thing I want to point out is this kind of might remind you of, I think it was the Chapter 4 test. So make sure you read all the directions. So this, just as an example, if you were taking the test and it said, are the triangles similar? If they are, state the similarity and a postulate or theorem that can be used to prove the triangles are similar to each other. So just make sure that you get all the pieces there, because I'd hate to see you lose points if you said, yep, they're similar, but you didn't give me a similarity statement, or which theorem or postulate can be used. So for this example here, if I was doing this, I would look at this triangle and I notice that I have information about there's two triangles, NOM and PQO. And so I have information about two sides of the triangle, and I don't have a lot of information about angles. So I remember that my three different things I can use the angle, angle postulate, right? Which basically means I have two angles that are congruent in one triangle to two of the other. Well, I don't have any angles right now, so that's probably not a good contender. I've got side, side, side theorem, right? Side, side, side similarity, I guess I should say. I have two of the three sides, and I don't have a right triangle, so I can't figure out the third side. Or I have the side, angle, side similarity theorem. All right, that's my other choice. So I don't have quite enough information in this picture yet, but the side angle side is promising because of my good friend vertical angles. So remember that NOM here and POQ have to be congruent because they are vertical angles, right? So when I have that, now I have, oh, voila, I have side, angle, side. So let me see if the side angle side theorem will prove if these two triangles are similar to each other. So first of all, I have to think about what my similarity statement might be. So my similarity statement might be, I'm going to start over here, I'm going to do NOM. So triangle NOM, how would that be similar to PQ and O? Well, if I look at N to O, that has a side length of 3. So that's longer than my M to O, which is 2. So looking at my triangles and kind of trying to flip them around to each other, right? I think that the triangle it would have to be similar to would be Q to O to P, because that would make N to O my longer side in the same position as Q to O, my longer side in the other triangle, right? And then O to M is my second two letters, and that would make it in the same position as O to P, which is similar over there. So I think that's going to have to be my similarity statement if it's true. And the next thing that I have to do is check if my similarity statement is actually true. So to do that, since I'm using the side angle side, right, I have already the angle part checked off. So now I just need to make sure that the two sides are proportional to each other. So I need to check that is N to O over Q to O in a proportion with O to M over O to P, right? And if I was doing side, 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 I would have to obviously check M to N and P to Q. But I'm not doing side, 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 so I don't have to check that one. Okay, so N to O is 3, Q to O is 6, O to M is 2, O to P is 4, and then voila, they all equal 1/2. So because of the side, side, side similarity theorem, and sorry for the crazy writing. Oh, I even did Christmas colors. I can say that the two triangles are similar. Yes, they're similar, right? And I would say that my similarity statement is that triangle NOM is similar to triangle QOP. Okay, so that's how we would do something like that. So make sure that you're looking at the whole triangle, make sure that you're writing the similarity statement and then doing the checks on there. If you happen to have a problem like that on the test. Okay, all right, so the other thing that I just wanted to remind you of, and I don't have a problem up here, so I'm just gonna kind of make something up on the fly, is what if I do have a triangle? Might as well use my triangle tool, right? Okay, I do have a triangle and I have another line. There we go. That comes across like, oh man, we got to do that again. We've got technology. We should be able to draw a straight line, right? Okay, there we go. So I have a triangle like this, and my first question would be is what if these two lines were parallel? Right? What if those two lines are parallel? Well, if those two lines are parallel, then the ratio of, so let's say that this is 4, and let's say that this is, oh, I don't know, what number do I make that be? Oh, we'll just make it easy. We'll make it really easy. This is 4, and this is 2. So that means that if this is 6 over here, then I need to define this side. Then I can find that by using a ratio. So theorem 6.5 says that if these two lines are parallel, then the distance from, and I have no letters on here, I apologize. So let me write some letters, A, B, C, D, E. So what theorem 6.5 says is if they're parallel, then A to B over B to C has to equal A to D over D to E. So in other words, in this picture, 4 to 2 has to equal 6 to X. And I'm sure you guys can figure out that X is 3 because I made it super easy, right? All right. And then another way that we could use this theorem is the converse, theorem 6.6. So again, I have this picture. Maybe, there we go. I have this picture and I say to you, let's see, let's delete some of these off of here. Okay. And I don't actually know if they're parallel or not. Ooh, maybe I should have just started over. I don't actually know if B to D is parallel with C to E. I'm not sure, but I do know that A to B is 4 and B to C is 2, and A to D is, let's say, 6, and D to E is 2. Okay, so if I know that these are the side lengths, in order for B to D to be parallel to C to E, theorem 6.6, then A to B over B to C has to be equal to A to D over D to E. So 4 to 2 over 6 to 2 has to be true. Well, that's not true. So based off of these numbers that are here, I could say that B to D is not parallel to C to E. So that's the other one that you want to make sure you understand for the test. And then the last thing that I wanted to go over is there are two problems with dilation. So remember dilation, we have a factor, a K factor. So K basically just means how much you're going to enlarge or reduce something. So if I had, 3 points, okay, and I had a point, I'm going to make this really quick for you. Okay. Okay, we're going to make a really easy shape, okay? I have a point here at 0, 0. I have one at 2, 0. And I have a point at 2, 1. Okay, I've got this triangle right here. And I said, I would like you to do a dilation, and the scale factor K is 2. Okay, so that means that you're going to multiply every point by 2. So 0, 0 multiplied by 2 is still 0, 0. 2, 0 multiplied by 2, I'm going to multiply both the x and the y by 2, and I'm going to get 4, 0. Okay, and then 2, 1 multiplied by 2 is going to become 4, 2. So you multiply 2 by 2 and 1 by 2. So here we go. 4, 2. So if I do that, my amazing drawing skills here, my dilation would be an enlargement, and my new triangle would be at 0, 0, 4, 0, and 4, 2. So just make sure that you're comfortable with doing dilations like that. So basically, that's it for the test. Like I said, you are more than welcome to try out as many of the Mad Libs problems as you want. I know it's a little different when you're at home. And then the other thing that I wanted to mention is the test that will be in class on Wednesday, if you're even in class on Wednesday. If not, you can just take it at home. Again, that test is over all of the entire first semester. It'll consist of test questions from chapters 1 through 6, primarily 1 through 5, since we just took the chapter 6 test. And I want you to just review, try to do your best, see how much knowledge you've gained. It's kind of a good temperature reading of how much of geometry you're retaining. And again, that test will only help your grade. It cannot bring your grade down. So make sure that, it's a good thing to practice, but not something to stress over. So if anybody has any questions over anything, chapter test, where to find everything, let me know. I have not sent out the chapter. The chapter 6 test is already out on Weebly, so you're welcome to take that anytime and send it over electronically. The chapter 1 through 6 test, I have not sent out yet because I honestly have not put all the pieces together yet. So I will be sending that out to you all soon. I think that's it. Again, reach out with any questions and take care. Bye, guys.